There are a number of different ways that you can create data inside OSM. These methods are based on polygons or visibility. So let's try polygons first. For each type of data that you want to create inside OSM, you should give it a unique name. And the idea of using polygons is actually very simple. You just select some regions and you assign values to them. For the rest of regions, you can select a default value. So if I want to select a region, I have to select a value for that first. Let's say the value of 3, and I can select a region. I can terminate the region by hitting enter, and let's say another region with the value of 6. And what I can do is actually I can draw regions that intersect with the barriers. The cell inside the barriers are not important to us. The simulations, none of the simulations actually use any of these cells, and they would not be used. So you can use your polygons in a way that you like with much more freedom. And let's say that we will select a value of 0 for the rest of the floor. If I hit OK and visualize the data, you can see that this is how the data looks like. So this is 0, and I guess 2, and then probably 6. And but for the rest of the floor, you can use another more sophisticated method other than giving a default value. And for that, we have to use an interpolation function. We need to have the regions that are the bases in both cases. So let's say that we want to give the value of 0 to this region, and probably this region too. You can see that I have removed this door from here, and then there is a neighborhood and there is an x in here. So to approximate the distance, x is actually going to be the distance from these two regions. So for instance, this region, this point in here is closer to this region, and this point is closer to this region, and the distances can be calculated accordingly. But how the distances are calculated? You see that we have a grid in here, right? And in this grid, each cell is connected to the other cells around it, and it will create a graph. So let me show you this one. Okay, in this image you can see that this is the cell at the center, and it's connected to two neighbors in each side. So this is going to be a larger rectangle which includes two cells in each direction. So in total we have 1, 2, 3, 4, 5 cells in a row, and we use this neighborhood template to calculate the distances in the graph. Technically we will not be using this one, because using this one is going to be equivalent to using this one. These are not going to be useful connections for us, and we will not be using them because we want to make it more efficient and fast. But what matters is that if you increase the number of neighbors, you will get directions, more directions and more cells, and the distance calculation will be more accurate. So this is one way to fight the effect of discretization on the floor. And with the neighborhood of size 8, for instance, you can get 17 a 17 by 17 rectangle and this cell at the center, which is pretty accurate and is a good approximation. So let's say that we have an 8 size for the neighborhood. You can change it, and then we have this x function in here, and that's all we need to do. So let's hit create, and let's take a look at our data. you can see that these are the default polygons that we have selected with the value of 0, and our interpolation function, which is nothing more than the distance itself, is actually uh, going to determine the rest of the floor for us, the value of the rest of the floor. And you can see that since this door is open, as you enter this door, this value is actually going to be different. You have to make a turn to get to this point, and this value is actually going to be different. So these values are the values that are determined by the interpolation function. Now we can do something more interesting. So let's say that we want to create a new field of data, give it a name, data3, default value of 0, let's say only this polygon, and you can use another function to do that. So let's say our function is going to be sine of okay, let's get an idea of how this function looks like. So see, this is the way that this function looks like. It's a wave that is going to disappear at distance, and if we apply it in here and hit create, then we can see that how our data looks like in the 3D environment. So this is a wave that starts from this point, and then it covers all of the floor, but the wavelength is going to disappear, and the magnitude of wave is also going to disappear. So this is a way of creating a fancy layer of data using Polygon method and the interpolation method.